Okay, so here's that question from WebAssign, and some things I'm noticing are, let's see, that they're talking about percentages or proportions. So this is about proportions, not the mean. So what we're going to check for is that normal approximation to the binomial distribution. In other words, is this binomial distribution normal if we look at it? So one way to do that is I think Dr. Stevens uses, if you take n times the population proportion, that has to be bigger than equal to 10, or maybe he uses 5. Different textbooks use different measures. And the other check is you're going to do the size of the sample times Q, or 1 minus your population proportion. That also has to be greater than equal to 10, or 5. It depends. Honestly, 5 is usually big enough. But so what about this one? So this is 236 people, and there's the success rate of 0.48. Well, that's almost half. That's going to be 140, which is bigger than 10. And since this is almost half, so that's met. And since this is almost half, I'm just going to pretend it is for a minute. I'm going to subtract it from 1, and what is that? 0.52. Again, that's almost half, which is going to be about 100 and 120 or so, which is more than 10. So yeah, we got a random sample. We got these conditions are met. So if we were to graph, that tells us the normal approximation of the binomial distribution tells us this is the normal curve. I mean the mean, and then because it is a binomial distribution. Here, let me clear this now. I mean, because it isn't a quote normal distribution and it's binomial, we can say, well, let's see. So the mean, because it's binomial distribution, we can say the mean is 236 times 0.48. And I'm going to actually get an exact answer here. Let's see, 236 times 48. 0.48, Dan, not 48. Let's see, 0.48. I'm getting 113.28. And then to get the standard deviation, remember that's the square root of n times p times q. So I've already done the n times p. So all I've got to do is multiply that by 0.52, because that's 1 minus the 0.48, right? Then I'll take the square root of that times 0.52, and I'll take the square root. So that's telling me I'm getting a standard deviation of about 7.67. That's hopefully enough to keep my Math Excel happy. Sorry, this is a WebAssign. We'll go 3 decimal places. That truncated, so we're done. All right, so that's the mean and standard deviation. So what's the z-score? Well, if there's 98 satisfied, let's see, if there's 98 of them satisfied. So 98 minus 113.28 divided by the 7.675. So let's see, 98 minus 113.28 equals, divided by 7.675. I'm getting negative 1.99. You were close. And then they're looking for the probability. So we could look at Dr. Stevens. Why don't we? Here, just let me pause my video and I'll go get that open. So we're going to go and like negative 1.99. Let's see. So negative 1.9, come over to 9. So the probability to the left of that is 0.0233. Definitely unusual. I know that's not quite negative 2, but it's a normal curve, so we know the probability of getting 98 people or fewer who are satisfied with their job is let's see, where I lost my place now. Is 0.02 or 2.33%, if you want to express it as a percent. Okay, do we have, have I answered all that questions? Yeah. And it's low, so it is unusual, right? Even your answer would have been unusual, because usually if it's less than 5%, that's a signal that, yeah, something's happening. That 48% number is probably a little too high, because we're getting a sample of a pretty big sample of 236 employees where it's less than that. Okay. I also want to make sure that you see David Lane's applet right here. Let me use this here. David Lane, because it is a normal curve, right? So David Lane normal. Make sure you do David Lane. I know I've said this in other videos, but if you search for David Lane normal, you'll get the right David Lane. But so what you can do, I mean, you can do this with z-scores, but we also, since we already know the mean, 1113.28, and the standard deviation is 7.675, and we want it below 98, right? And what does that give us? Pretty darn close to what we did by hand, okay? So, but you don't have to find the z-score here. To keep WebAssign happy, we needed the z-score, but you could have done it this way. Okay, so hopefully that helps.